Hello everyone, my name is Joako Samuel. I'll be taking you through SS1 mathematics, new general mathematics for SS1 students. I will try to go through all of them. So if you have any loved one in SS1, please do well to tell the person to like, subscribe, and share this video to the person so that the person can see it. Because we're going to be doing this together in this channel. So want to start with chapter one. Sorry. Uh, SS1 new general mathematics for SS1 of SS1, and I want to start with chapter one. So there are four topics in that chapter one that a student should be able to know, and they're all connected to each other. We have the indices, we have the standard form, we have the logarithm, we have the anti-logarithm. So everything about chapter one is about these four topics. And of course, they are very important because they are all connected to each other. You need the knowledge in indices to at least handle standard form problems. You need standard form knowledge also to at least handle logarithm problem. And for you to solve anti-logarithm, you need to get your logarithm. So logarithm is like the opposite of anti-logarithm. This is front. If you are go from here to the other side, from the other side to this place, that's anti-logarithm. So these are four topics that are in that SS1 Usual Mathematics for chapter one. So what do we mean by indices? Indices is about index. It's the plural for index. That is to say, of course, when you hear 2 square, 2 cube, right? You've been hearing that before. That is or 2 to the power of 2 or 4 no square or 5 square. So this is what we are referring to as indices. The index is the power on top. So another word for indices is power or raised to power. So when we have problems like this that are in this order of index, how do we add them? How do we multiply them? How do we divide them? What are the so how do we handle problems like this? So that's what SS1 chapter 1 want to expose you to on how we're going to be solving problems that are index form. Now, standard form is any form is any form that can be is any form written like this: a times 10 to the power of what n. So if you can write any whole number in this form, you have written it in standard form. So when they say standard form, they mean writing a number in this form. So what if you have problems like that in standard form? How do we add? How do we solve such problems? So these are the things you'll be seeing in standard form. And logarithm is it's also very simple. What we are doing here is to handle questions. Let's say we have uh, we have an equation like we want to make n here the subject, for example. We need logarithm to do that. We want to bring it down. Like let's say if I have my y equal to x to the power of n. So how do we bring down this n in this form? Let's say if we have this and we have this. Okay, if here is 2 and 2 is equals to 3x, and they say find x. So finding x here is the use of logarithm. So this thing this will um this is equivalent to this is equivalent to okay let me quickly drive you there. So find x. So how do we find x? So that is the essence of logarithm. Let me write it again. Let's say I have 2, right? 2, or let me just say okay, let me use a particular function. Let's say if if okay 100 is equals to 10 to the power of x, what is x? And they say what is x or find x. So our x here is the same as we multiply. So that's the work of logarithm. Logarithm will help us to find the x. So to bring down x here to be in the form of 100 is equal to this is what we call subject of the formula. So that means we are making x the subject. So how do we do that? We multiply log to both sides. So we multiply log to both sides. Log 100 is equals to what? Log what? 10 to the power of what? X. And also, so our x can comfortably return back now. So I have log 100 is equal to x log 10. So I can divide both sides by log 10 and what log 10. So log 10 will cancel log 10. So that will give me, let me use this please. I'll be having x is equal to what? Log 100 over what? Log 10, which is something as what? Log. So for log 10 to be the base, it's also written as log 10 of 100. So log 10 over 100. Or, okay, let me log 10 of 100. So our x, our x, we're going, when we come to logarithm, you understand. So our x here becomes equal to what? Log 10 of 100. So log 10 of 100 can also be broken. So we have tried to make it. I'm stopping there because I'm not teaching you logarithm now. When we get there, we'll understand. So we break it down. So when we get there, you understand what log 100 over 10 means. It will give you what your x is. But what I want to explain to you is that logarithm is, so if we have 100 is equals to 10 square. So our x here is always 2. But that's the essence of logarithm. But in your SS1, they are not taking you through this type of logarithm. What you're going to be doing is logarithm of numbers, where where you will be uh, asked to use log four-figure table, log table, to find your value of x and y. So these are the things you're going to be seeing there. So here you'll be using logarithm of numbers. So it's logarithm of numbers. So So where you'll be asked to use logarithm table to achieve your goal. But all of them are connected, right? So um, that's the first topic. So in our you're going to follow us in our next slide. We'll be looking at these topics, individual like that. So we're going to look at them separate. So there, in the next slide, follow me. You're going to see 10 laws of indices. Some people normally say it's 7 laws, 6 laws, or whatever. But I'm going to be showing you 10 laws of indices that will enable you solve problems that are of index form. A to the power of x. Any problem that is of index form. So I'm going to be giving you 10 laws that will enable you solve such problem. So by the time we do that, we will go to the next one and next slide. So follow me in the next slide as we check. Let's go. Thank you for watching. If it's your first time, please do well to subscribe, share, like.